Okay. Yeah. Okay. Remember, right? Hoi, was soll geschenkt zu meinem Jammerke? So, das.
Was geschenkt zu meinem Jammerke?
Ich weiß nicht, aber mein Jammerke hat gehabt und ich weiß nicht, was geschenkt zu. Ich weiß nicht, was das geschenkt zu meinem Jammerke. Oh, du ist es. Du ist die Jammerke. Es hat gefallen, und ich habe reingelegt den elektrischen Strickel dort. Verstehst? Und du verstehst nicht?
Ja.
Okay. Ja. Okay. Du bist... Okay. Jetzt. Now about reden ein bisschen... Wir werden reden in Englisch, okay? Und wir werden lernen ein paar Sachen heute. Okay? Es gibt interessante Sachen in Mathematik. Okay. So, if you have a number, okay, and you multiply it by 100 and then divide it by 100, what will you have?
The same number.
Okay. If you multiply it by x and then divide it by x, what will you have?
That same number.
Okay. Well, that's the idea behind...
so, y times x divided by x equals y.
Correct. And how do we know this?
Because we do.
Huh?
Because we do.
Right. All this time, all these weeks I've taught you and why we know things, and now...
we learned it empirically.
Very good. We learned it empirically. That's what I want you to say. Okay? All right. Yes. Is it self-evident? Oh, you don't know what self-evident means. Let me write this down.
What? And you're writing self-evident.
How did you know? Okay. What's written here?
Self-evident.
Okay. That comes from two Latin roots. Vid means to see, like video, right?
Yeah.
Vid means to see, and e means out of, or from seeing. Evident. The ent is a, you know what that is.
Yeah. Suffix.
Very good. That's what I wanted you to say. Okay, so you've got the suffix ent, which I think is probably to make it a word, a noun. It is self-evident. It is evident. Evident must be a noun. I hope. Maybe it's a verb. No, it's a noun. Okay. E means out of, seeing. So evidence is something that you can see that tells you something. For example, okay? If you know, like those pecans that Plain Bubby sends all the time, the jar of pecans.
I know them.
Okay, so now if the jar is full, and I'm in the house, and for a day or two, and then you see the jar is half full, that is evidence that what?
You ate out of the jar.
That's evidence, okay, that they understand? So evident means that there's evidence, okay? And self-evident means you yourself can see something, okay?
Yeah.
All right, so is it self-evident that if you multiply a number, if you multiply by x and then divide by x, you multiply a number by x and then divide by x, that it's the same number? Is that self-evident?
Well, yeah, because you see it.
Well, okay. I'm going to tell you something, okay?
What?
Nothing in our universe, and nothing in our universe is really self-evident. People say that something is self-evident, but how do we really learn it? We learn it
empirically.
Right. And things that are always that we empirically see are always true. After a while, we say, "Oh, it's self-evident," but that's just because we say that. That's just because we always see it to be true. But if you're a baby, nothing is self-evident. You learn things when you're born. You don't know any of this stuff, and you learn everything. How?
Empirically.
Very good. All right. So it seems like you might say, well, it's self-evident that if I let go of this pen, it will
fall.
But it's actually okay. But anyway, all right. So if you have y times x divided by x is always y, right? That's self-evident. Okay. So now that's the whole idea behind scientific notation. But scientific notation is I'm going to write something, and now I'm not going to...
human concept.
Not concept?
Construction. Construct. That's what I meant when I said...
Yeah, well, concept is also a good idea. Concept means an idea. It's a human construct. Okay? So, there are a lot of things that are human constructs. Virtually everything we do, that we say, that all kinds of concepts that we have, and you know the word concept, right? What it means, an idea, are really human constructs. Okay, God didn't give it to us; we created those constructs. Okay, watch this.
Scientific notation.
Right, scientific notation is a human construct.
Yeah. And
that's because it turns out it's useful. Why it's useful is it makes things easier for us.
Yeah.
Okay, and I will show you, and not today, not today. Some other time I will show you why it's useful. Okay. All right. But now, let's say I give you a number like 1,359. Okay. And we want to get into scientific notation. Okay. Write it in scientific notation right here. Let's see if you learned anything from everything I taught you. Read it.
1.359 times 10 cubed.
Correct. Or 10 to the third. Let's show that over here. Let's see. Can people see it?
Yeah.
Okay. Very good. So, look. What did you actually do? And I'm going to show you that what you actually did is you divided by 1,000 and you multiplied by 1,000. Can you see that or not?
Oh, I don't know exactly. Well, because 1,000, if I divided it by only 10, I'd have, like 13.
What would you have if you divided by 10?
13.59.
Wrong.
Wait, divided by 10.
1,000.
1,350. No, 135.9.
Okay, so give me that. All right.
And then if I divide it by 100, I'd have 13.59.
Okay.
And if I divide it by 1,000, then I'd have 1.359.
Okay. So look. So if I write 135.9, you know I've divided it by 10, correct?
Yeah.
But, so now I've changed it. So now I've got to multiply it by 10, correct?
Mm-hmm.
So I'd write, do you understand?
Yeah.
Now it's the same number, isn't it?
Yeah. But
now, if I write 13.59, I've divided by...
you divided by 10 to the second power, or 100.
Yeah, I divided it by 10, by 100, by 10 to the second power. So therefore I have to multiply it by to keep it the same number. Do you understand?
Yeah.
Right?
But you can't have that because it has to be between.
Well, you can. That's a perfectly correct number.
Yeah,
it's just
but
not.
it's just not scientific notation.
Correct.
You can't have that as scientific notation.
Okay. All right. So look, I don't want you to learn algorithms for how to do things. I want you to be able to understand what you're doing. Okay? Because if you learn algorithms, stoicht nicht. You know what I mean? Stoicht nicht doesn't help you. Right? It's worthless.
Yeah.
Stoicht nicht. Okay. So now, let me start so that I make sure you really understand, all right, the scientific notation. I'm going to do something. Look at 1,359, right? Divided by 10, right? Now, do you remember that you can write that as 1,359 times
1/10.
Very good. Remember, division you can convert into a multiplication problem by taking the
inverse.
Very good. The inverse of the thing that you're dividing by, which has the divisor, I think it's called. Okay? Okay, so now, here we go. So now I'm going to do the following. I'm writing down 1/10 times 1,359. Okay? By the way, 1/10 can also be written as 10 to the
-1 power.
Correct. Okay. Now, I'm going to use the distributive property of multiplication. First of all, I'm going to say it's 1/10 times, and I'm going to put parentheses, okay? 1,000 plus 300 plus 50 plus 9. Is that correct or not?
Yeah. Yes, it is correct.
Okay. Now, the distributive property then tells me the following. That's 1/10 times 1,000, right? Plus
1/10 times 300.
Plus
1/10 times 9.
Times
50.
Right. You could say 9 for it doesn't matter, yeah. And then plus
1/10 times 9.
Okay. Times 9. Okay. What is 1,000 divided by 10?
100.
What is 300 divided by 10?
30.
Plus 30, right? What is 50 divided by 10?
5.
What is 9 divided by 10?
0.9.
So therefore, this can now...
135.9. Oh, yeah.
So therefore, when you take 1,359 divided by 10, do you see that you've really just moved the decimal point over 1? Because the decimal point is understood to be here, correct?
Yeah.
All right, let's now take... Okay. So now let's just take 1,359 and let's divide it by 100. That's the same as 1,359 times
100.
Times 100. Times 100. Right?
Mm-hmm.
And of course, multiplication is commutative, right?
Yeah.
So that's the same as 100th times 1,359. Correct?
Yeah.
Yes or no?
Yes.
Okay. All right. By the way, 100th can also be written as 10
to the -2 power.
Okay. All right. Very good. So now I'm going to take this 100th times 1,359, and I'm going to expand 1,359, okay?
Yeah.
I'm doing nothing but expanding it. 100 times 1,000, right? Plus 300 plus what?
Plus 50.
Plus
9.
Okay. Now I use the distributive property. How did we learn that the distributive that multiplication has a distributive property? How did we learn that?
Because we learned empirically.
Correct. Can we prove it?
No.
We just assume that because it works every time we try, it's true, right?
Yeah.
And you know, when we do that, what are we assuming actually? When we do that, we're actually assuming that they're Eibishter.
Yeah.
And they're God. Their Eibishter created the universe, so there's certain things that are always true. You see?
Yeah.
You understand?
Yeah.
So that's. And why do you think the Eibishter did that? It's just a theory, because a theory means why. I remember I told you why you can't. How many answers are there to a why question?
An infinite amount.
Right. So we're just guessing, but my guess is the reason that the Eibishter did that he created our universe such a way that there are certain things that are always true, is because it lets us make wonderful things, right? It lets us build. I'm going to write a word here. It lets us invent. And here's the word, and let's see if you know how to read it.
Technology.
Right. Technology are things like cell phones and televisions. You couldn't make a cell phone if every time the rules in our universe changed. You understand?
Mm-hmm. Yeah.
And also, it'd be kind of not good that if sometimes you let go and the pen drops, and sometimes you let go and goes floating. Or like, you take a jump. Sometimes when you take a jump off of a chair, you get to the ground, but other times you take a jump off the chair and you end up in the ceiling. That would be kind of disastrous, wouldn't it?
That would be funny and cool.
Oh, you'd like it, okay.
Well, that would be kind of cool.
Alright, so now, writing this out, the distributive property. So we have 100th of 1,000 is what?
Only 10.
100th of 300 is?
3.
100th of 50.
It's a half.
Right.
Which means, and that's the same thing as 0.5.
Okay, so that's 0.5, right? Alright, I like to write 0.5, but it doesn't matter. 0.5, right? 100th of 9
is 0.009.
Wrong.
No, it isn't.
What is 100th of 9?
100th of 9.
Just don't think about how to write it. What is it?
100th of 9 of 9 is 9 divided by 100.
And what is it?
900th.
900th. And how do we?
0.09.
Okay, so why did you say 0.009?
I don't know. I didn't mean to.
Yes, you did mean to.
No, I didn't.
You wouldn't have said it if you didn't mean to. What you should say is, I wasn't thinking. I just blurted out because I figured I'd guess and I'd get the right answer.
Well, I didn't want to guess.
Okay, but
I just.
Okay. Well, why don't you think? Okay, so there you go, right?
I confused myself because I thought
so 9 divided by 100 is 900ths, correct?
Yeah.
And 900ths is written like this, correct? Because here are the tenths and here are the hundredths.
Well, so 0, I thought that was supposed to be point. I forgot that I'm not supposed to put it there.
No, yeah. Sure.
Stop it.
Tell me another Bubba Mice. Okay, so let's put that together. 10 and 3 is
13.
Point.
59.
So what happens when you divide by 100? Look, what happens?
It's supposed to be here. You move it 1, you move another, and you're here.
two places. Okay. All right. You understand that?
Yes.
Okay. Let's say okay. Let's try something else. Okay, because I don't want you to ever forget it. Let's do 1,359 divided by 1,000.
Okay. That is equal to 1,000
Yeah.
times 1,359.
Okay.
And
Then write equal here and then break it up.
Equals 1,000 times.
Yeah. Period. A period is better.
Yeah.
Okay.
I meant to do period.
Okay.
Times 1,000 plus 300. Oh, come on.
Write it above. Write it above. 300. Yeah.
300.
That's 300.
Oh, come on. 300
Yeah.
plus 50
Yeah.
plus 9.
Close parentheses. Okay. And now we're going to use the distributive property. Okay. So write it out. So what is 1,000 divided by 1,000?
1.
Plus 300 divided by 1,000.
0.3.
Okay. Do you understand
3/10.
why?
Yeah, 3/10.
Because 300. Well, it's because it's 300 thousandths, right?
Yeah. And that's the same thing as 3/10.
Right. Yeah. Yeah. Do you understand? Yeah. You do understand why, right? 300 thousandths is 3/10. Okay. So 0.3, and then 50 divided by 1,000 is.
Well, is 50 thousandths.
Right.
And 50 thousandths is the same thing as 500.
Correct. Do you remember this
Yeah.
thing? Because 50 thousandths, right, is the same as 5 times 10 and 100 times 10, correct?
Yeah, and
But-
then you can just cross this out and this out and you get that.
Right. And with just 500ths, it's actually also a 20th. I don't know if you realize that.
I didn't really realize that.
You do realize it or not?
Well, not at that moment. I didn't realize.
Okay, but you do know that, right?
Yeah.
Okay. So 500. So write 500ths over here.
Oh, come on.
All right. Okay. And then 9 divided by 1,000 is.
0.009 or 9 thousandths.
Okay, write down 9 thousandths.
0.
The zeros for the tenths. Hundredths.
Thousandths.
Okay. And of course, all of. Okay. So now you're going to add these up.
Equal.
When you add up 1 and another.
0.35 and then there's 9.
You see that?
Mhm.
Okay. So when you look, when you take 1,359 and you divide it by 1,000, what have you done?
You made it 1.359. You divided by.
Yeah, I mean, I just want you to notice that you moved.
I know you moved the point, the decimal point, to the left.
Okay. Well, another way to see that is, if I move the decimal point over to the left once, I've divided by 10, right?
Yeah.
If I move it over once, again, I've again divided it by 10, again divided it by 10, right?
Divide by 100 and then you divide it by 1,000.
Okay. So in other words, if I start with 1,359, right? And let me divide it by 10 and multiply it by 10, okay? So if I divide it by 10, Okay, you're not going to look, right?
Yeah,
You're going to look. You're going to look at the podlige, right? I'm moving the decimal point over 1, right?
Yeah.
But to keep it the same number, I then have to multiply by 10 to the 1, correct?
Yeah. Oh.
Now, if I take this 135.9, you divide that by 10, you get
13.59 times 10 to the second power.
times 10 times 10, right? You got to
Yeah,
go. You already have the 10, then you got another 10, so it's times
10 to the 2, or 10 to the
second power. Now, if I divide this by 10 again, right? You're going to move the decimal point 1 over, correct?
Yeah.
So it's 1.359, but I divided it by 10, so I have to multiply it by 10.
10 times 10 to the third.
Do you understand why?
Yeah.
All right. You do understand why?
Yes, I do.
Okay. All right. All right. So
did you write on the other side of this?
Oh, I did. Yeah. Oh, why? You don't like that I do both sides?
No, I like it. I would just want to know this because the last few times you just didn't.
Oh, I didn't. Okay. Oh, okay. I didn't realize that. Sorry. Yeah. Okay. So you understand that, right?
Yeah.
Okay. So now, let's say I have have 12 and I multiply it by 10.
120 is your answer. Cause and you
120.
And you can then one way to think of it. So 12 is the same thing as 12.0.
Okay.
And then when you multiply it by 10, you move it over 1
to the
right.
Okay.
Equals 120.
Right. But now, if I multiplied it by 10 to keep the number the same, so 12 equals 120 times 10 to the...
Well, 12 equals 120 times 10 to the negative 1 power.
Correct. Because I multiply by 10, I have to now divide by
10.
Do you understand or
not?
Okay. 12 equals 1200 times 10 to the...
Times 10 to the...
Correct.
Because you multiply by 100, you gotta divide by 100.
Okay, good. Now, I'm going to do something else, alright? I'm going to see if you really understand things or not, alright? Well, let's do it this way. 12 equals 12,000 times 10 to the...
12 equals 12,000.
Because you understand, to get 12,000 from 12, I had to multiply by 1,000, right? You understand that, right?
Yeah.
So therefore, I have to also divide by 1,000, which is multiplying by 10 to the minus 3, multiplying by 1,000. 1,000th, yes? Okay, you understand that. All right. Now let's take a different number. All right. Let's take something different. By the way, what's it say here? Oh, we've been at it for 29 minutes. Okay. Let's take something else. Let's take point 3857. Okay? Okay. Now, if I take 0.3857, or you can even say 0.3857, right?
Yeah.
Times 10. Okay? Now I'm going to show you something, okay?
You're gonna... Well, can I just see what
okay, well, see what you can do. See what you can do.
I think the answer will be
correct. It will be. Now let me show you why, okay? Because commutative property of multiplication is that this is the same as 10 times 0.3857, correct?
Mm-hmm.
Now I'm going to rewrite 0.3857. I'm going to rewrite it as 0.3 plus 0.08, right? 3/10 plus 800 plus 5,000 plus 10,000. You see that?
10,000.
Okay. Yeah. Okay. 10 times 3/10.
10 times 3/10 is 30/10.
Yeah?
Yeah.
Okay.
10 times
3/10. Oh yeah, it's 30/10, right.
Which is
You are
3.
absolutely correct. It's 30/10.
Which is 3.
30/10. 30/10.
Yeah.
Right?
Yeah. Which is the same thing as
Yeah, which is 3. Okay.
3.
Oh, you know what? Let's take one step. Let's take one step further, okay? Let me do an intermediate step, okay? I'm going to write this out as 10 times 3/10 plus 800, right? Plus 5,000. Do you see that?
Yeah.
Plus 7 10,000. Right?
Yeah.
You were very right. You were right. You know what? And I was about to say you're wrong. It's 30/10. You're right. You know why?
Why?
Because I stopped thinking for a second. I expected a different answer. You gave me the correct answer, but you gave it to me in a different way, and my brain wasn't flexible enough. Right?
Yeah.
And my brain wasn't flexible enough to think about it. When I thought about it, you're right. Okay. So 10 times 3/10 is
30/10 or 3.
right. So this is equal to 3. Now 10 times 800.
80 or 8/10.
80 or 8/10, right? You understand that? You understand why? 8/10 plus 10 times 500. 5,000. 10 times 5,000
is 50. Is 500.
Right, good. 50,000.
Or that's also equal to 1/20th.
No. 500 is. You're right.
1/20th.
You know, you're so correct. What is the matter with me? You know what I have to do?
What?
Oi! 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 Nicht das euch klieg. Oi! Ich bin nicht das euch klieg. Oi! 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 You're right. You're right. Plus 10 times 7 10,000
is 70 10,000, which is equal to 7,000.
Okay. Yeah. Because you understand how you can eliminate 10 from the top and bottom, right?
Yeah.
But you understand why you can do that, right?
Yeah.
Okay. You know that 70 10,000 has to be 7,000, right?
Yeah.
You understand that. Okay. So that's equal to, let's write it down now in decimal notation.
3.857.
857. Oh, 857. Okay. Right. So therefore, that's why you understand that when you multiply by 10, you're just moving the decimal point
1.
Okay. Now, a lot of people just memorize, oh, I just moved the decimal point, and they never check or understand why. I don't want you to do that, okay? That's known as, you just learn a rule, you learn an algorithm, how to solve math problems by algorithms. If you do that, you're never going to be a really good mathematician, right? Do you want to be a good mathematician like your Peter Noam?
Yeah.
So you have to understand things, okay? You know what I mean?
Yeah.
Okay.
Noam's a good math.
Okay, so every time you multiply by 10, you're moving the decimal point
1 to the right.
Okay.
And then
So
when you divide by 10, 1 to the left.
Okay, so now I'm going to take the same number, 0.3857, and I'm going to multiply it by 100, okay? Now I'm going to do it in 2 steps. You know about the, I don't know if there's a name to that property. 3.857. Well, it doesn't matter what order you multiply in. When you multiply 3 numbers, does it matter in which order you multiply them?
No.
How do you know that?
Because multiplication is commutative.
Okay. Well, it's associative, I think. I think it's called associative property. You can associate it any way you like. In other words, here, that's called the okay, you know what?
And put it in any order.
Right. Division is not associative, I don't believe, but multiplication is. Let me write this.
Yeah, but
in other words, look, x
5 times 7 is the same.
X times y times z is the same as x y times z, where you multiply x y first and then you multiply z. It's the same as x times y z.
It's the same as x, y, z.
It's the same as x z times y. But that's called the associative property. In other words, it doesn't matter which order.
Yeah, I thought that was a commutative property.
No, the commutative is when you switch. X, y is equal to y, x.
Yeah. 5 is 7, like 5 times 7.
This last part was
5 times 7 is equal to 7 times 5, but 5 divided by 7 is not equal to 7 divided by 5.
Right. But okay, that's called, here, I'm going to write this down and let's see, because I never taught you this word.
Associative property.
Now I'm going to show you something else. A plus B plus C, okay, is this, you can get that, the answer to that is the same as A plus B, where you add A plus B first and then you add C, and it's the same as A plus B plus C. So you can do B plus C first and then A.
Yeah.
You understand?
I know. Yeah.
That's called what kind of property?
The associative property.
Right. And then what I can do is something else. I can use the commutative property to write A plus B plus C as A plus C plus B, right? They're the same.
Mm-hmm.
What did I use? I used the, B plus C is the same as C plus B. And then I can do, this is the same as A plus C, and then add B. Yeah. Understand? So in other words, it doesn't matter, the order doesn't matter. And that's called the associative property. Okay?
Yeah.
Okay. Let's now go back and do the following. I'm giving you the same number which was over here. 0.3857, okay? Right? 0.3857, and I'm going to multiply it by 100, okay?
Mm-hmm.
But now here's what I'm going to do. 0 point. Okay. I'm going to write it as 0.3857 times 10 times 10. Do you understand? Mm-hmm. So if you multiply by 10, forget about this part. Just do the 10 times this, because there's the associative property. We figured out that when you multiply something by 10, the decimal, what happens?
You move the decimal 1.
In which direction?
To the left. I meant to the right. That confused. I'm serious.
Yeah, that's a multiply. That's a multiply. Yeah. To the right. So therefore, I can rewrite this as 3.857 times 10. Do you understand that?
Yeah.
Now, to multiply this 3.857 by 10, what do?
Move the decimal point 1 to the right.
So therefore, this will be equal to, well, you write it down.
This is equal to 38.57.
That's right. Okay. So now, if I have 0.3857, right, times 1,000, what will be the answer? Write it out and tell me why. Are you sure?
Yeah. I know.
And why? So tell me why.
Well, because 1,000. Well, this is the same thing as 3.3857 times 1,000. Wait, so it's 1,000 times 3/10.
Yeah, no, you don't need to do that. No. Yeah, we already showed that, okay? I just want to show you something. Here's what I'm going to show you, okay? That this is the same as 0.3857 times 10 times 10 times 10.
Yeah.
Right? And every time you multiply by 10...
Move it another, move it another. I mean the other way. Move it one, move it another, move it another, and it's going to be
okay.
Here.
So in other words, okay, right. So 0.3857 times 1,000 equals 0.3857. I'm going to write it in a different way, times 10 to the third, correct?
Mm-hmm.
That means you're multiplying by 10 3 times, and each time you multiply by 10, what happens?
Each time I multiply by 10, the decimal point moves 1 to the right.
Okay, so do you understand? So you see why it's kind of convenient when you write 10 to the third? You write 1,000 times 10 to the third. Tells you, it actually tells you how many places you're going to move the decimal point.
Yeah, because it's 10 to the...
Okay.
I'm going to go to...
Well, what are you doing? Where are you going? Oh, okay. Then I'm going to get something. I'm not going to tell you what I'm getting. All right, I'll be right back. Okay, we'll be back. Hey, we're back. Okay. Now, I'm going to give you a problem. And let's see if you're thinking, okay?
Mm-hmm.
Don't guess. I want you to think. All right?
Mm-hmm.
123,000, all right,
Mm-hmm.
is the same as 1.23 times 10 to the what?
Well, 1.23 times 10 to the second power will be 123.
Yeah. Very good. You're right. You're right. So read it.
123,000 equals 1.23 times 10 to the fifth power.
Okay. Do you understand that to get to this, you have to multiply it by 10 5 times, right?
Mm-hmm.
That's why 10 to the... Because what you really did was, here you divide it by 10, 1, 2, 3, 4, 5 times. You understand?
Yeah, and then I have to multiply by 10 times.
You understand that?
Yeah.
Okay, very good. All right, you're beginning, you know what? You're starting to scare me.
Why?
Because you're starting to think instead of guess. That's scary. All right. Now, let me do another one. 0.00359 equals, okay, 0.00359 equals 3.59 times 10 to the what?
Well, 3.59. The decimal point is here. I divide it 1, 2, 3. 3 by 10 to the third power to get to that from this, right?
Yeah, but yeah.
So I multiplied it by 10 to the third power to get from this to that.
Right.
So times 10 to the negative 3 power.
You're scaring me. You're scaring me. Oi, that's my destruction. Yes. Okay. Let me actually. Now, this is going to be a little bit difficult. How would you read this number? In other words, if you have to say it out loud, you can say, how would you say it?
0.00359.
Okay, right. That's, yes, but I'm going to tell you, I'm going to show you another way, okay?
Uh-huh.
That we can say it, okay?
359,000.
Right.
Is that what you want?
Well, is it 359,000?
No, it isn't. It's 359,000.
That's what I wanted you to say. Right. Look. Here's the tens.
Yeah. Hundreds.
Thousands. 10,000.
100,000.
900,000. 5 10,000, which is 59,000. 3 3,000s, which is 310,000. 100,000, right? 300,000, but 359,000. 10, 100,000, 10,000. Yeah, correct.
Yeah.
All right.
Yeah.
Okay.
Mm-hmm.
So, that's correct. So now I think you've really got it. Okay.
Mm-hmm.
So let's say if I were to say to you something like, 125 billions in scientific notation. 125 billions. Now write it out. Okay? 125 billions in scientific notation. First write out the 125 billions. How would you write that?
Well, 0.10 hundredths thousandths.
Right.
10,000, 100,000, millions, 10 millions, 100 millions, billions.
Okay, so there are the billions. I said 125 billions.
So that means that it's actually...
Correct. I liked how you did that. Correct. Very good. So therefore, you go 0, 0, 0, 0, 0, 0, 1, 2, 5. Correct?
Yeah.
Yeah. Here,
so that
here. So you know that the billions are here. Here are the thousands, right? You know the comma. Here are the thousands, right? Right to the left of the comma. Here are the millions, right?
Yeah.
Here are the billions, and you need 125 billions. So here's the spot for the billions. Go 125, right?
So
now write that out in scientific notation.
1.25.
Right.
Exactly how did I get there? Well, I multiplied by 10 to the 7th power. But then I have to divide it by 10 to the 7th power, so it's times 10 to the negative 7th power.
Correct. Let me show you something, okay? So that you can do things pretty quickly. All right. If I say, here is a thousandth is 10 to the minus 3, correct? This is a thousandth, right? Right? 10 to the minus, okay. A millionth is 10 to the minus 6.
Yeah.
Okay? So, right? That would be like that, correct? 10 to the minus 6, right? Millions. A billionth is 10 to the minus 9, right?
Yeah.
Billions. Let's go another one, just trillionth, okay?
10 to the minus 12.
10 to the minus 3, 10 to the minus 6, right? 10 to the minus 9.
This is going to be 10 to the minus 12.
Okay, so you see this, right? Right? That's the trillionth, right? 10 to the minus 12. Okay. So now, look. Let's say I wanted you to write 5 trillionths in scientific notation. Do you understand? I'm going to tell you, and it'll tell me if you understand why. Okay. So 5 trillionths, right? Instead of writing all of this, 1 trillionth is 1 times 10 to the minus 12. So 5 trillionths
is 5 times 10 to the minus 12.
Good. You understand that, right? 10 to the minus 12, right? Okay. A billionth is 10 to the minus 9, but if I go 9 billionths, it's
9 billionths.
It'd be, if 1 billionth is 1 times 10 to the minus 9, right? So 9 billionths is
9 times 10 to the minus 9.
Okay. All right. So now, if let's say I say, let's go to the billions, okay? 5 billions is 5 times 10 to the minus 12, right?
Yeah.
Let's say I say 23 billions.
Yeah, 23 billions.
Right, 23 billions. Okay? If I say the word 23 billions, which I could write as, like this, right? Like this. another one, and you understand that that's 23 billions,
Yeah.
right?
Uh-huh.
23 billions, you know, is the same as 23 times 10 to the minus 9, right? But that's not scientific notation. What do you got to do now?
2.3. But since I multiply that by, or I divided that by 10, I gotta divide that by 10.
Right.
So that's gonna make it only 10 to the minus 8.
Very good. I like it. You understand how you can do that very
Yeah.
quickly now? Do you understand why you can do that quickly? Okay. So let me show you. Okay. Let me see if you really understood by me giving you another problem. And let's see, you know, just think about it. Don't jump. Think. If I were to say to you 125 trillions in scientific notation, all right?
Here, can I write it down? Because it's probably easier.
Yeah. I'm gonna write the words down. Okay.
No, I mean like the number.
Yeah. 125 trillions. Okay, doing scientific notation.
I meant like
Write it down. Write it however you like.
0.10s, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, trillions.
No.
And actually,
Thousands, millions, billions. You just did billions.
Oh yeah. So
Not trillions.
now 125.
Right.
Okay. So now equals 1.25 times 10 to the something power. Okay. Now I'm getting to 1.25 by multiplying it by 10 to the 10th power.
Mm-hmm.
So now I got to divide by 10 to the 10th power.
Right.
Meaning.
Correct. Now let me show you now an easier way. So the answer, you got the right answer, and we're going to show it right on here so people can see. Right? Can they see?
Yeah.
Okay. Now I'm going to show you the easy way. Okay.
Uh-huh.
The way you did it is the way the people at Helm would do it. Now let me show you the easy way. Okay. Look, we said a trillionth is.
People in Helm would do it. There's a weird way to get the answer wrong.
Right. So that was you're not doing it like the Helm people. Okay. Remember, look, I told you. We saw here that a trillionth is 10 to the minus 12, right?
Mm-hmm.
1 trillionth is 10 to the minus 12.
Oh, right.
125 trillions
is
1.25. Wait a second. Wait. 1 trillionth, right? 1 trillionth, right? Is the same as 10 to the minus 12, right?
Yeah.
125 trillions, look, is 125 times
10
to the minus 12. But that's not scientific notation, so how do you get that 125?
You divide this by 10 to the second power.
Right, which means you gotta
divide this by 10 to the second power.
You have to what?
Multiply this by 10 to the second power.
Right.
Which gives you 10 to the 10th power.
10 to
negative 10th power.
Okay. Do you see?
Yeah.
Do you see how you can do that very quickly for that reason? Huh?
Yeah.
Okay. Right. So because you see, you wrote it all this out. Okay. But look here, right? You wrote it all out. This is 5 trillions, right?
Yeah.
So this is 5 trillions, but so you could write it as 5 trillions, then there would be and another 20 125 trillion here, so 125 10 to the minus 12. Do you understand?
Yeah.
And that's why it becomes this, right? Okay, you understand now, right?
Yeah, I do.
Okay.
Understand.
All right. So now we've gone a long time already. How much time?
1 hour, 1 minute, and 28 seconds.
Okay.
29
All right.
seconds.
Now I'm gonna show you something. Okay. Now I'm gonna show you something. Okay. Let x be equal to 0.0.333 forever. Forever.
You put a bar over that.
Okay. Wait.
Boom. I didn't think that would happen, or maybe I did think that would happen.
You never empirically, that never occurred to you? You've never experienced that empirically?
Yes, I have experienced.
So why did you do it?
No.
Okay. So now, what I need you to tell me is, what is 10x equal to? 10x is equal to what? Write it down. Think. Think. Don't just write. Think. Okay. So now, I want you to do that is correct, by the way. So let's write that down. Let's show that, because you're a pretty smart guy. All right?
Showed.
You showed, okay. Now, I want you to do the following. I want you to do 10x minus x is equal to.
10x might take away x?
Right. And look over here, and what will that be? Look at these two numbers and think.
Okay. Well, x is... so 10x must be equal...
10x minus x.
Minus x equals 3.
Okay. So 10x minus x equals 3. But what is 10x minus x? How many x is that?
9x.
So 9x equals 3. So what do you think x is equal to?
X is equal to 0.33334.
Wait a second. Here.
Oh, here.
Divide both sides by the same number. So you get just x here. What do you have to divide 9x by to get x?
By 9.
Okay. So x equals
3 divided by 9.
3 ninths.
3 ninths.
And 3 ninths is what?
3 ninths is 3 ninths.
Simplify it.
Yeah, okay. 3 ninths is 1/3.
Okay. So what did we just show? We just showed that if x equals 0.3 forever, it's equal to?
It's equal to 1/3.
Okay. So now, let me give you a different problem, okay? And this is what I'm going to finish up with. I'm going to do maybe another 10 minutes to show you something. Let's say x equals 0.7777 forever, okay? I want you to tell me what x is in fraction form. You see, you just converted x from decimal form, 0.333333 forever, from decimal point to fraction point to a fraction, and you saw that it was 1/3. X equals 0.7 with the bar over it. Okay.
So should I do the same thing with 10?
Try, yeah. Well, that's the method I showed you, right?
Yeah. So 10x equals 7.7 with the bar over it.
Okay. So what is now what is 10x minus x?
10x minus x equals...
Okay, but 10x minus x is?
9x.
9x equals 7, so what is x equal to?
Well, x, I divide that by...
Right. Well, you know, if 9x is 7, you've got to know that an x is...
X is 1. No, X is 7/9.
Okay, well, you can understand that, right?
Yeah.
Because if 9x was 1, then if 9 of those x's were 1, then x would be 1/9, right?
Yeah.
Okay. All right. So now I want you to tell me the following, okay? Just tell me if x equals 0.5 with that bar above it, 0.55555 forever, x in fractional form would be what? Do you think you can generalize? Do you think you can induce the answer, or do you have to go through it?
Head.
No, do you think you can induce from seeing here? From seeing what happened? X equals 0.3333, you got a third. X equals 0.77777, it's 7/9. Okay, do it and let's see.
Well, here I got 3/9. Here I get 7/9. I'm gonna think that maybe it's 5/9.
Okay, right, 5/9. But why don't you actually do it? Do 10x. Let's try it. 10x would be
10x equals
And you understand why, right? Because of the distributive property of multiplication, right? Do you remember that?
Yeah, and then 10x minus x. 10x minus x equals
5, right?
Not which equals 9x equals 5.
Yeah. Then you know that
x equals 5/9.
Do you understand why?
Yeah.
If 9 of those x's equals 5, right? Each one, if you divide by 9 to just get x, each one of those 5 is a 9, so there's 5/9, right?
Yeah.
Okay, you understand that. All right. So now I'm going to give you, this is the last thing, okay? And this will require you to actually think. All right?
Make me think. Make me think.
That's right. I'm going to make you think. All right?
Well, if I want to get the answer right, then I have to think.
You actually have to think. You can't guess. You actually have to think. All right?
I could guess. If there's
okay.
Coins, they basically...
X equals, okay, here. 0.1212
I'm guessing that you're going to put a bar
over the 1, 2. So let's just write it as x equals 0.12 with a bar over the 1, 2. Do you understand?
Yeah.
I want you to tell me what x is in the form of a fraction.
Okay, so 10x equals 1.2. So 10x minus 10x minus x is equal to what? X is I'm up to there. 10x minus x is what?
Okay, let me give you a hint, okay?
Mm-hmm.
You're going about it the wrong way.
I'm thinking of it the wrong way.
Yeah, think. Well, it might work. Let me see. Okay, let's see. So you've got 10x, right? You've got 1.2121212, etc., right? And x, you've got 0.121212. Be pretty difficult, right, to figure out what that would be, because this goes on forever, right?
Mm-hmm.
Can you think of another way to do it, that you could actually figure out what the fraction is? I want you to think, is there another way that you can do it? that you make it nice and clean. When you subtract something from something, you'll get something that's very clear. Is there another way to do it?
I don't know. Well, is there another way to do?
Is there some other thing to do?
To find the ends.
Yeah, just think about it. Look at this. 1, 2, 1, 2, 1, 2, 1, 2.
There's 2, 1, 1.
Yeah, but look how it alternates here, right? You think you can do something that it doesn't, that this and this are just cancel out? Is there something you could have done? Because here you can't, because there's a 2 here and a 1 here and a 1 here and a 2 here and a 2 here and a 1 here. And that doesn't exactly cancel out, does it?
Yeah.
Well, what do you think you could have done to make it cancel out?
Wait, these?
Yeah.
All of these?
Well, here you have x, right? What do you think you could have subtracted this x from this 0.121212 from that would cancel out just like with the 0.3 did, with the 0.7777? What do you think could have done?
It just went by. Well, maybe I could multiply the point by. Yeah, maybe I could multiply this by 10. That would do nothing.
Multiply what by 10?
The number.
Which number?
This or this. This or this number.
Which number? This?
Or this number.
Well, this number multiplying by 10, you got this.
Oh yeah, so this number multiplied by 10.
Go ahead and see what happens.
Will be 12.
Okay. 12. And that would be how many x? Here you have 10x. What would that be?
That would be 100x.
Okay, so why don't you write that down? This is 100x equals this, right?
Yeah.
And now, what do you think you're going to do? You've got, here's the x, here's the 100x. What do you think you're going to do?
I'll subtract x
from
100x, which would give me just 12.
Okay, and 100x minus x is what?
Minus x is 100x minus x is 99x.
So 99x equals what?
Equals 12.
So what do you think x equals?
Well, I could divide this by 99.
Yeah.
So then there would be x would equal 1299.
And can you simplify that?
1299, maybe. Oh, I think so, probably.
Yes, but 1299 is correct.
Yeah, 12.
Okay. You understand that let's say 99x equals 1, then x would be 199th, right?
Yeah.
If 99x equals 2, then x would be 299ths, right? You understand that, right? So it's not just because you're doing a rule, divide both sides by 99. Yeah, you understand what you're doing, right? Yeah. Yeah, 1299, there is a common divisor for 12 and 99. What is the common divisor for 12 and 99?
Divisor?
The divisor for 12 and 99.
3.
Okay, so make it simpler. 1299 says, hold on. Oh, Belleville.
It's Robin.
Huh?
It's Robin. Tata.
What's up, Tata?
It's Robin. No, if you heard this Robin, Tata stuff.
433.
Robin.
Okay, die weiß bloß, ich die Mathematik mit dem Samen.
1299.
Right.
It's 433.
Perfect. That's what, now I'm beginning to be proud of you. Okay, I'm starting to be proud of you. All right, I'm going to do one last thing and then we finish off. Okay? One last thing. All right. Let's see if the brain is working or it's not working. Let me see. Maybe I can look inside there and see if it's working or not. Okay. Here we go. All right?
If you could go into your own brain, you probably could create anything in there because
right, why?
you're thinking
it just appears because it's your brain.
Right. Okay. Look. Here we go. X equals 0.125 with a bar over it. So 0.125, 125, 125, 125, 125. Okay. Can you tell me what X is in fractional form? As fractions.
I don't think if I multiply by 100, that's just gonna bring me to not so good places.
No.
Maybe 1,000 will do it.
Well, let's see. What would 1,000 do?
So 1,000 x equals 10 x equals 1.25, 1.125,
Yeah, okay, no.
100x would equal 12.5, 125, 125. 1,000x would equal 125, 1.125, 125.
Right. You understand that, why? Right, because 1,000 is 10 to the third, right? And you move the decimal point 3 places to the...
Right.
Okay, so 1,000x is
125.125.
Okay, so now what are we going to do? We're going to do
1,000 x minus x.
And what would that be?
Equals, well, that's canceling x, which is that, so it would be 125.
Okay, so and 1,000x makes
999 x equals 125.
Right. So each x is equal to...
Now, so I'm going to divide this by 999, right? So that's x, and this by 999, that's 125, 999.
Okay, put an equal sign in here. That's correct. Okay, I want you to understand, if 999x is 1, let's say 999x is 1, then x itself is 1 999th, right?
Yeah.
If 999x is 7, then x is 7 999ths, right? Okay, and if 999x is 125, do you understand that?
Yeah.
You really understand, or you just... Yeah, okay. Correct! Now, here's the point then, okay? I want you to induce, okay? Oh, I wanted you to read it.
Induce.
Yeah. Or do...
Induction.
Induction is a synonym for induction, or another word for induction is...
Generalize?
Yeah. Yeah. I'm going to write it down.
Generalization.
Right. It's generalization. You generalize, right? Yeah. And from here, what I want you to realize is that any decimal that repeats, can be written as a
fraction.
Correct. Okay? So, I'm going to write down, and then we're finished.
Can I write it down?
Alright, you write it down. Let's see if your spelling is good, or you just...
Any decimal that repeats.
Alright.
That repeats.
Right. You have an extra E here. Yeah, repeats you had right, except for that E. After the T, right.
Repeats.
Right.
Can be written as a fraction.
Yeah.
Can be...
Write down over here.
Written as a
let's hold it up here. Okay. Right.
Any decimal. There.
Yeah. Okay. Now listen. So therefore, okay. Let's say you had something like this. If you had a decimal like this. 0.1234 with the bar, so it repeats. You would be multiplying it by how much?
By
If you said x equals, and you'd make how much?
Or you can multiply it. Should multiply it by. That would bring you to nothing. That will bring you to nothing. That will bring you to nothing. That. I don't know if that would bring you to nothing. Oh yeah, 1, 2. It would be 1,234.5. 1, 2, 3, 4. So multiply by 10 to the 5th.
Right.
100,000.
Exactly. And then right, and then you'd subtract the x from 100,000 x, right?
Uh-huh.
And then you get 99,999 x equals, right? Okay. Do you see that any fraction that repeats, any decimal that repeats, you're going to be able to get into the form of a fraction, right? Okay. So irrational numbers. The reason, you know what irrational? Okay. You know what the definition is of this?
It can be written as a fraction. Yeah, they can be written as a fraction.
The irrational. Ir means not.
They can't be written as a fraction.
Right.
Or
they cannot. Right.
Like pi.
Ir means not. Yeah. They cannot. And do you know why they cannot? Well, one of the signs is they do not never repeat. Do you understand?
Yeah, like a
if they repeat it, could you write it as a fraction?
Yes.
That's right.
Just like the square root of 2.
Right.
It doesn't repeat.
Square root of 2 never repeats.
Yeah.
It's irrational, so therefore you can never write it as a
fraction.
Right.
You can't even write it as a decimal.
Okay. Look. Read this word.
Rational.
Exactly. You cannot write it as a decimal. Exactly. Rational. Rational has the word, this word in it. What do you read this?
Ratio.
Ratio. You know what ratio means?
I'm used to.
No, ratio means something divided by something.
Yeah.
You can say, look, when the word 2/3, okay, at this number, right, 2/3, you can say is the ratio of. You understand?
Yeah.
It's a ratio of 2 and 3. It's 2 divided by 3.
Yeah.
2 divided by 3 gives you 2/3. You understand?
Yeah.
Because 1 divided by 3 is a third. 2 divided by 3 is 2/3, right?
Yeah.
1 divided by 99 is 1/99th, right? 13 divided by 99 is
13.99.
good. Okay. You are done, my friend.
Thank
you. Did you like this today's lesson or not?
Yeah.
Okay. I always think I can cover more than I can, but now you're going to be very good with scientific notation, right?
Yeah.
All right. Okay, hold on. We gotta stop this. I'll stop it.
I want to stop it.
Okay.
I want to